Right, so another past examination question. So this is an Edexcel question from C4 January 2008, and this was question 4 of that paper. So let's have a read. So in part 1, find the integral of ln x over 2 with respect to x. So let me copy that down. So here's part 1, the integral of ln x over 2 with respect to x. Now, to integrate ln, we need to integrate by parts. So in this case, let me write down the by parts formula. So by parts, and here's the integration by parts formula. So integration of u dv over dx with respect to x, and that is equal to uv minus the integration of v du over dx with respect to x. Now, if you're unaware of integration by parts, I have created a video and I'll give the link to this video in the description below. So in that video there will be added examples of how we integrate by parts, so be sure to check out that video. So let me continue with this example though. Now, if you're integrating ln in particular by parts, I would say choose u always to be the natural logarithmic function, and dv over dx will be the remaining term when it comes to applying the by parts formula. So as you may know, so we need to choose our u and dv over dx such that the integration of v du over dx is easy to integrate. So I suggest that whenever you have an ln term to integrate, always take u to be the ln term, dv over dx will be the remaining term. So in this instance, I'm going to take my u to be ln, and it's ln x over, so it's x over 2. And with u, we need du over dx, so du over dx. When I differentiate ln, it's 1 over, so it's going to be 1 over x over 2. But you need to multiply by the derivative of x over 2. And let me continue further. When I differentiate x over 2, we're going to get half. And in this case, when I go one stage further to tidy this up, so I'll do this as a side calculation. So the half below will cancel with this half above to give me simply 1 over x. So that is going to be the result for du over dx. However, dv over dx, so let's continue, let's do another side calculation. So for dv over dx will be the remaining term of this integral. So in this case, I'm sure that you would agree that I can write this integral as ln x over 2 multiplied by 1. So in other words, I can write this integral as a product of two terms. So I've chosen my u to be ln x over 2, which means that my dv over dx is going to be 1. Okay? So let me emphasize it more clearly with some colors. So as you can see, my u is ln x over 2, and if I pick up a different color, maybe a green pen, my dv over dx, I'm taking that to be 1. So if I go back to my favorite color blue, my dv over dx is 1. However, we need v. So we need v to apply this by parts formula, so we need to integrate dv over dx, which is 1, with respect to x, and when I integrate 1, we'll have x. Now when using a by parts formula, don't add the constant of integration here, we'll add the c at the very end. Let's apply this data to the by parts formula here. So let's go one stage further. So I have the integration. Now generally speaking, when you replace the data for u and dv over dx, it should correspond to the question. So let's have a look. U is ln x over 2. dv over dx we've chosen to be 1. So if you multiply the two, you do indeed get our question. So on the left you have the ln x over 2 with respect to x. However, on the right we're going to have uv, so u is ln x over 2, so let me copy that down. So ln x over 2 multiplied by v. V in this case is x, so multiplied by x, minus the integration of, in this case, v according to the formula. So v is x, so multiplied by du over dx, and du over dx is 1 over x. Now don't rush with the calculation, so first try and make it smaller, so I can definitely do a cancellation within the integral to give me 1. So when I do the cancellation, the result of which will give us 1 to integrate. So let's go one stage further and simplify. So we'll have x ln x over 2 minus, and as I said earlier, we now need to integrate 1. And if I continue, so we'll have x ln x over 2 minus, when I integrate 1, we're going to get x and add the c here at the final stage. So this is going to be the solution, and this is the solution of part 1 of this question. So part 1 is now done. Now let's have a look at part 2. So let me do part 2 over here. Let me copy down the question first of all. So part 2, we need to integrate between limits pi over 4 and pi over 2. And we need to integrate sine squared x with respect to x. Now to integrate sine squared or cos squared, so if we want to integrate sine squared x or cos squared x for that matter, we need to use the double angle formula for cos. So in this one, we need to use the double angle formula for cos, which connects the sine squared only. So in this case, let me write that down. So we're going to be using, so let me make a side note, we're using the fact that cos 2x, the double angle for cos, and it's 1 minus 2 sine squared x. So we need to use the formula for the double angle for cos, which is in terms of sine in this case. And this is the very one. Now, we need to rearrange this for sine squared. So if I rearrange for sine squared, so let me go back to blue. So rearranging for sine squared, firstly 2 sine squared x. If I take this minus 2 sine squared term to the left, and at the same time the cos 2x term to the right, 2 sine squared x is 1 minus cos 2x. And now if I divide both sides by 2, so if I divide both sides by 2, I'll have sine squared x, and that is equal to 1 over 2 minus cos 2x divided by 2. So that is what you're going to have upon rearranging for sine squared. Now let's go one stage further and let's integrate this term on the right, which corresponds to sine squared when rearranging the given identity. So let me rewrite the integral first of all. So between limits pi over 4 and pi over 2, and replacing the sine squared x by this term on the right, so let's do that. So let me copy down the half minus cos 2x over 2, and let's carefully integrate this term with respect to x. So opening up a square bracket, when I integrate half, it's half x, or x over 2. When I integrate cos, it's plus sine, so it's plus sine 2x, divided by this 2, but you also need to divide by the derivative of the angle. Okay, so if your angle term is linear, if it's of the form ax plus b, you need to divide by the derivative of the angle. So the derivative of 2x is 2. Let me close that square bracket. Let me write down the limits, pi over 2 and pi over 4 here. Now, if you're unaware with trigonometric integration, I have created videos in the past and I'll provide links to those videos in the description below. So be sure to check out those videos to perfect integration of trigonometric terms. So let me continue though. And if I tidy this up prior to replacing the limits, I'll have x over 2 minus the sine 2x. Whoops, so let me make that more clearer. Sine 2x divided by 2 into 2, which is 4. Between the limits, pi over 2 and pi over 4. Now, let me replace the limits. So upper limit replace first. So I'll have, replacing the x's here by pi over 2. So we'll have pi over 2 on top, divided by 2, minus the sine, 2 into the pi over 2, divided by 4. So that is what you should have upon replacing the upper limit. Minus, and if I replace the lower limit, pi over 4, so replacing these x's by pi over 4, so let's carefully do that. We'll have pi over 4 divided by 2 minus sine 2 into pi over 4, close brackets, divided by 4. So that is what you should have upon carefully replacing the limits. And let me continue over here. So as far as the first bracket is concerned, pi over 2 divided by 2, so that would be pi over 4. These two 2's, as far as the angles are concerned, will cancel. Okay, and if you calculate sine pi, so sine pi when calculated should give you 0. So you got 0 from this term. Minus, so let's figure out the second bracket. So pi over 4 divided by 2 is pi over 8. This 2 will cancel with the 4 twice. And sine 90, if you calculate sine 90, you should get, or sine pi over 2 rather, which is the same as sine 90 in degrees, you should get 1. So that's a standard result. So minus 1 divided by 4. So the 4 comes from the denominator. And if you simplify this overall, pi over 4 minus pi over 8, so that is going to give you a 1 over 8 pi, or pi over 8. So pi over 8. So I've simplified these two terms. Minus into minus is plus, so it's plus 1 over 4. So I'm going to leave my answer like this in terms of pi, and that should be the solution to part 2 of question 4. So part 2 done. So that completes this question in its entirety. So I hope you enjoyed this video. If you did enjoy the video, be sure to like the video and subscribe for more content like this, and I hope to see you again. Thank you.